Lecture 15, Hydraulic Machinery Part 2. The topic is System H curve. Okay. This is for System H curve is for pipe system. Okay. The energy input to water flow by using a pump explained in terms of the increase of the head water. Total head equal to static head plus the friction head. And for the static head, it comes from difference between the suction and discharge elevation. Okay, this is suction and this is discharge elevation. And for the energy loss from the flow due to the combination of the friction head loss and minor head loss. Okay, suction and discharge elevation of the pump are normally constant, except the elevation is vary from the river tide is rising or falling. Okay, we will show the example later. This curve shows the static head of the pump is constant, and this is for the friction head is increased with the Q, and we combine static head and friction head, we got the system head curve of the pipe. While for the friction head is a parabola function because of the if, for example, if we prove that if Q1 and Q2, if Q2 is about 2 times of Q1, so V2 is about 2 times V1, and for velocity head, point 2 is the 4 times of point 1, and because of head loss is function of velocity head, so we expect that head loss at point 1 is equal to 4 times of point 2. So we prove that we got the parabola function. Okay. And system head curve is used to describe our condition of the water flow and used to select the appropriate pump. And intersection point between the system head curve and HU curve of the pump is the working point of the pump. Okay. And this graph shows the characteristic curve of the pump that we learned from the hydraulic lab, and show the relationship between this pump discharge and head. So you see that for the head is once the Q increase, the head decrease. Okay, and the other between Q and power input and Q and efficiency. Okay, and we plot the HU curve of the pump here compared to the system head curve. Okay, the green line is the HU curve of the pump, and the orange line is the system head curve of the pipe. The intersection point we call the working point between pipe and pump. Okay, is similar for this, but this one for different the type of the pump. So this is steep HU curve. That is the matching point. The efficiency of the pump can be defined from the HU curve of the pump, and impact on the pump operation can be defined by the system head curve due to the change of the pump context. For example, suction and water elevation are vary, or flow rate is changed. Okay. From previous classwork, we practice to find what is the head. We use the Q max and we find just the one head, and we don't know what happens if the Q is less than 0.07 or head is greater than 33. So for this system head curve, we can draw the curve or condition of the Q and head. Okay, and this is show example of the condition of the pump is changed. For example, if the water level in the river for T1 in this level, for T2 is decrease of the water level in the river. So we expect that the static head increase from H1 to H2. Okay, and this is static head increase from H1 H2, and we got the delta H is a difference of the head. Okay, and for the intersection point, that is this HU curve of the pump, and this is system head curve change from the working point change from point 1 to point 2, okay, because of static head is changed. And in this case, the Q is changed from Q1 to Q2, decrease to Q2. But if we choose the steep HU curve of the pump, we can find that the Q2 is come closer to Q1 if we choose the steeper HU curve. So that is the one we can choose the pump that fit to our condition. But if we want to get the head, this one, the head is more changed, we can choose the smile HU curve. That is mean that if the static head is changed, but the pumping head is still come closer.